Good morning, students. So today I'll cover a dual converter. So as you can see here, the dual converter consists of two converters connected in anti-parallel. So there is a positive converter and there is a negative converter. The positive converter applies voltage to motor in one direction and negative converter in opposite. So in this way, a bidirectional voltage can be applied to the motor. And regarding current through motor can be bidirectional, and it is also bidirectional towards supply. Now, why we need two anti-parallel converters? The reason is unidirectional semiconductor devices. So SCR cannot allow reverse current. So for that you have to connect another SCR in anti-parallel. Therefore, two anti-parallel converters are connected. Whereas, as you know from the operation of 6-pulse converter, when firing angle goes beyond 90 degrees, the output voltage goes negative. So voltage can be positive if firing angle is less than 90 degree, and it can be negative when firing angle is more than 90 degree. Same is true for another converter which is connected in anti-parallel. Let's say it is a negative converter. So this converter provides positive voltage when firing angle is less than 90 degree, but positive of this converter is opposite to the motor. Okay, from reference of motor it is opposite to the motor. And again, this converter gives negative voltage when the firing angle is more than 90 degree. But from motor's point of view, its voltage will be opposite. Okay, so we have to set some reference point, and accordingly we have to mark the polarity. So whatever is shown in the figure, these polarities are reference polarities. So whatever direction of ID going through armature is shown, it is considered as positive current, and whatever is the direction of VD or polarities of VD shown, that is the positive voltage. So this converter will work in all four quadrants. Means it can apply positive voltage, positive current, then positive voltage, negative current, or negative voltage, negative current, and also negative voltage and positive current. Now, the firing sequence, the operation. Now the two converters can be operated singly in single converter mode. That means for operation in first and fourth quadrant, that is with positive voltage positive current and negative voltage positive current. First and fourth quadrant, a positive converter can be used, and for operation in third and second quadrant, negative converter alone can be used. The problem with this single converter operation is the utilization is not full. Utilization of this system is not full. So we are talking about very high power converters, because dual converters are very high power converters. Generally, they are employed in very high power applications. So utilization is very important, because already heavy costs are invested in the system. So when single converter operation is done, it is not good utilization of the system. Then switching between modes is also quite difficult. Switching between the modes is also quite difficult. So it is very convenient to go for
Hello?
So it is very convenient to go for. So for simultaneous operation, the firing angles of two converters are adjusted such that alpha 1 plus alpha 2 will be equal to 180. So if alpha 1 means firing angle of positive converter and alpha 2 is the firing angle of negative converter. So simultaneous operation gives very fast dynamic response. Switching between the modes is very easy, very smooth, and utilization of the converter is also very good, or maximum we can say. But there is a problem of circulation current between the two converters, because the instantaneous voltages of two converters are not equal and opposite at all instants. So there is some voltage difference between the two converter voltages, and due to that the current flows between the converters in the outer loop, and it will not flow through the load. So you can show it here. The path of the current would be like this towards supply, and then again this path. So in outer loop, the circulation current flows in outer loop. So this mode is also called as, means the simultaneous conduction mode is also called as the circulation current mode. Now what is the problem of circulation current? If this current is not opposed, or any opposition is not provided to this current, then this current flows directly through the converter between the converters, and it creates overheating of the converters. It's like short circuit, isn't it? So we can avoid this by giving some opposition. It is done with the help of current limiting reactor. Current limiting reactor is placed here, this way. So some reactance is added to positive converter side, and some reactance is added to negative converter. So this balances the impedances on both sides, and this also limits the circulation current. So for these very high power drives, dynamic response and utilization of converter is very, very important. Dynamic response means whatever we want, change in the speed or reversal of the speed within some specified time. So that will be done very smoothly. Obviously, heavy losses are or extra losses are incurred due to this insertion of inductance in the circuit. But we have to bear with these losses as we are concentrating on the 4-quadrant operation as well as a very good dynamic performance of this drive. So this is a 3-phase dual converter I have shown. Even though you can also use it for single phase purpose, in that case 2 single phase full bridge converters are connected in anti-parallel. Let's see the waveforms. So there is VD plus and VD minus waveforms. As I have told you that firing angles of positive and negative converter are adjusted such that their addition is 180 degrees always. This is the rule for simultaneous operation mode. If this rule is followed, then we get symmetrical waveform and very less circulating current. So just have a look at the waveforms. Obviously they are not the same at all instances. That is, the voltages are not same at all instances. You can see this voltage here is negative. At the same time, this voltage is positive, and their instantaneous values, their magnitudes are also not same. So there has to be circulation current. So you can check this out. The net voltage, okay, which is seen across the inductor, is V small r. This is the net voltage observed across inductor, and inductor current is also shown. The circulation current is shown, and the voltage across positive converter is also shown. VP is voltage across the individual SCR. Okay, voltage across individual SCR is shown. So this individual voltage across individual SCR is actually voltage blocked by 8. So you can see easily the above 2 waveforms. If we check out the missing parts from the waveforms, so that missing part of the voltage is appearing across the non-conducting valves or non-conducting thyristors. So waveform is just like a converter with inductive load. Check out the firing angle. Okay, it is less than 90 degree for first converter, then it is more than 90 degree for second converter. So in that way, they both act simultaneously, and they apply a positive or negative resultant voltage to the motor. This is a converter redrawn, simplified. Okay, this is also the dual converter. So applying firing pulses in proper sequence is very important. Connecting the current limiting reactor is very important for simultaneous current operation. So in this figure and even in this in the previous figure, the current limiting inductor was not shown, but that is very important component when simultaneous operation has to be done. Okay, so this is what a dual converter is. There is nothing special about this thing, because the same converters which we use for a two quadrant operation, same converters are connected, but they are connected in anti-parallel, and there is a set rule for simultaneous operation, that is the relation between two firing angles. Positive converter firing angle plus negative converter firing angle must be, and their addition must be 180 degrees, and we have to add extra current limiting reactor or inductor in the circuit to limit the circulation current. So only that is the thing. Obviously we get a voltage which is almost double that of the individual converter output, so that also we have to consider. Okay, their firing angles are adjusted such that their voltages becomes additive in nature, so we get almost double output than that of the individual converter operation. So if we simulate or if we draw the combined voltage waveform, in that case we will get the idea about the voltage. So that is what all about dual converter. So very important when dual converter is used. So it is used for mostly high power applications, and whenever four quadrant operation is required. It is not you can say highly efficient, but it gives very good dynamic performance, and it serves our purpose, that is four quadrant operation. So that is very important. So that's all for dual converter.